Welcome. We are live on the Sidetrain LinkedIn. Thank you so much for joining us. Gareth is my name, and we are back with what is now episode 5. I know, time is passing so fast. Episode 5 in our ongoing series, How Do You Solve a Problem with Maria? And of course, Maria, my good friend Maria Machado is here with us today. Maria, how are you getting on? Everything okay?
Yes, everything is perfect. Still
Fantastic.
warm outside.
That's awesome. Have you had a good Publishing Integrity Week, Maria? How's it gone? Has it gone well?
It's gone well. Lots of discussions. A lot of figuring out what to do with problems that arise. But I think that people are trying to get methodologies to fight paper mills and issues with integrity. But I think today we'll just probably focus on things that you didn't know were bad
Yeah,
and you weren't
right.
supposed to do.
Right. I mean, our focus is on researchers rather than on publishers and
Yeah.
journals and editors. So, in this event, at the end of Publishing Integrity Week 2024, brought together by the wonderful Committee on Publication Ethics, COPE, of course, we're going to be talking about common research and publishing integrity issues that you didn't know that you weren't supposed to do. So let's get started, shall we, Maria? Let's have a look, because this is one of our favorite presentations. And of course, we're Sidetrain, and if you'd like to put any comments or thoughts or, insights into the LinkedIn Live chat, you can, of course, do that just by commenting directly on this post. Maria, why are ethics so important in the research and publishing cycle for researchers?
Well, researchers, they ensure accuracy and reliability of what it is that you're doing. They ensure that people are given credit for the work that they do. But they also aid in collaboration. If everything is set in advance and you know your role and you know what you're supposed to do, then you're less likely to have fights further down the line. So also, it's incredibly important that you then talk to your funders, to the people that gave you money to start your project, and assure them that you have followed the proper rules.
And we find when we talk to researchers around the world that many of these issues are actually things that people didn't know they weren't supposed to do, or are areas where they could do with a little bit more training, in particular around the use of funding, aiding collaboration, promoting scientific integrity and trust. So what we're going to do in this event today is we're just going to go through a few of the most common areas where we find that researchers do have issues, and there are slip-ups and there are problems in the research integrity cycle, because this matters all the way around the publishing cycle, right, Maria? Like, ethics matter at all stages of this research life cycle for
Yes, it matters whenever you're asking for funding, whenever you're reporting the funding that you received, and if there's any conflicts of interest between what you have been given in terms of money and your own livelihood and the data that you've collected, but also the publishing, copyright, submission, peer review, and most importantly, as well, to figure out how to stay clear of predatory journals, conferences, because those, if you do then publish with one of those venues, then you won't be able to publish the same data in a reliable one because you won't be able to
exactly.
compare.
Exactly, and that happens because people don't realize that they've done something wrong, that they've replied to an email or submitted a paper to a journal that's not completely legit. And I don't know, doing courses with Sidetrain, talking to researchers around the world, we find, or at least I would say, that plagiarism and the ethics of writing are one of the areas where most people have confusion. And we're going to talk quite a little bit about statistics in this presentation. But writing, Maria, a few words first of all on plagiarism. Like, that's something that researchers often fall foul of in the ethical
Yes.
process, right?
Yeah, but that's a lot to do with, first of all, there's only so many ways that you can describe something that you've done, and it still remains correct and clear. So, methodology is often an area where people are quite keen to not write things over and over and over again. And I understand that, but some journals still don't take the methods out of your plagiarism check. And if they don't, then you are highly likely to have lots of strings of text that are similar or equal to something that you yourself published before. And that's another thing that people don't realize, is that plagiarism is also whenever you say something you've said before in exactly the same way, because you're auto-plagiarism, it's auto-plagiarism, self-plagiarizing.
You got to cite, if in doubt, cite those sources. And that's
Yeah.
something that people often don't do, like taking content from another paper, even slightly rewriting it and putting it into your next piece of work. You must cite the original source. But we're going to get into the 7 deadly sins. These are areas where researchers often have problems and fall foul of publishing research integrity issues. Maria, let's get started. And these are not just deadly sins, they're also food themed, which is something that we do like as well, Maria and I. So we're going to talk a little bit about that as we go through these. But let's start with sin number 1, which of course is data hacking. Maria.
So data hacking has a lot of ways that people can do this, and these are the most common ones. It's harking, cherry picking, p-hacking, salami slicing, double dipping, not publishing negative resources, and fabrication. Of course, that if you go from top to bottom, it starts to get more and more serious, right? So fabrication, we won't even get there today, because it's just, you're just making up stuff that you didn't do. So that by then you are highly aware of what you're doing. But for instance, the first one, which is harking, it's something that people sometimes do at the end of a project because they've seen something that is neat. And we like those things because we're geeky. So we like to see whenever our graphs and our data kind of follow trends and why it is that they do things. And then we start thinking about, oh, maybe it is because of this, and maybe it is because of that. But if it's something that you didn't think about to test from the very beginning, from the design of your study, it may just be that you're hypothesizing after the results are known. And that is harking.
Absolutely key. I mean, these different ways of manipulating data after you've done the analysis to fit back to a preordained or preconceived hypotheses are all kinds of data hacking. And these are ethical issues, integrity issues, and it's worth being aware of them because, of course, before you start to collect your data, you're going to be testing a hypothesis. So that's where data collection and data design comes into play. And of course, we have training courses on that. So if you'd like to get in touch with us, talk about data analysis, statistics, data design, we'd love to talk more to you about this. But hypothesizing after your results are known, Maria, this is a classic area of problems for researchers in terms of integrity, right?
Yes, because it's very alluring to kind of confuse, even for yourself when you're writing, especially when English is not your first language, to confuse correlation with causation, right? So if something is correlated, if it happens in tandem with something else or at the same time or follows the same pattern, it doesn't mean that one causes the other. It means that it may just mean that it's fluke, that it's a chance. And because of that, because it wasn't something that you designed from the beginning, it wasn't one of the confounders that you were correcting for, then you're highly likely to find correlations that are spurious, that have no meaning to what it is that you're testing.
The literature is full of these spurious correlations. We just put one example on this slide, the number of comics published against the robbery rate in Vermont. And of course, there's a correlation, but there's no causation, of course not. So, be aware of that. It's a big issue. And it's, of course, deadly sin number 1. What about cherry picking, Maria? I kind of know what this is. And I like the fact that it has to do with cherries. I'm a big fan of cherries, not at this time of year, of course, but what is this and how can we avoid this?
So it's when you are conducting a study, and sometimes it goes on for a long period of time. But it is very important that control and experimental groups are sampled at the same time with randomized allocation to minimize any biases. That means that whenever you're collecting data for an extended period of time, you always have to keep yourself in the loop to what your study design is, because there are some things, and there are always issues that it's incredibly important to control for, even if it is something that you would look back and say, oh, I should have controlled for this, and I didn't have a control that was for this variable. And it is very important to always, at least in tandem, have, for instance, if you're dealing with mice, like I did for a long time, you had control groups and experimental groups. It was important to pick them from the same litter, to pick them from the same age, to always do surgeries if you wanted to in the same day for different groups, because those are all things that you would find could vary and could then distort your data. Also,
And if you have,
if you always have to explain what you did with missing data, or if your analysis you didn't include everything, why it is that you didn't include everything.
so another example of how you can manipulate or do something that you might not be aware is unethical after the fact, after data collection. So harking is the first one, cherry picking data is the second one, and I think this is probably my favorite one, and a very common thing that researchers tend to do. You'd never really know about this if you're looking at the analysis after the publication, but if you're dealing with non-significant results, like, what does that mean? I mean, negative results often, unfortunately, as researchers, lead us down like a kind of dead end, and we think, well, that wasn't a particularly successful experiment. What can I do to make it into a successful experiment? And that's something that you should never, ever be doing. This is p-hacking, right, Maria? It's a big no-no.
It's whenever you designed an experiment and you collected all of your data, and something is on the cusp of being significant, and your p is equal to 0.05, and your heart breaks because it's not significant, and you are then tempted to perform an equivalent test, to collect more data, to use directional tests, so one-way p-tests, to perform sequential analysis, which is whenever you have multiple analysis of the same data. And that is basically a fishing expedition. You're doing parameter tuning. You are, whenever you're identifying outliers, if it's not something that you controlled for and you defined preemptively, then you should include it in your data. Whenever you're cleaning up data, it's not really something that you should perform without explaining the reasons for doing it and without having a proper justification, because then you're just attempting very, very neatly to fit your notion of what should be to what actually happened.
And it's really, really tempting. I know, I've been there myself. You're almost significant. Like, let's just tweak a little bit the data. Let's just do a bit of, manipulation to get it over the line. And this might be a stupid question, and I'm not a statistician, but why do we put so much, relevance on this particular probability significance?
Well, you really shouldn't, because it's not any more or less important than other things like the confidence intervals and ranges that you should be aware of. But it's just simple. People take it as something that's just simple to convey. If p is less than 0.05, then it's probably significant, because it's not random. But it may be not random because of lots of different reasons.
I see. Well, it's important to be aware of this, because, of course, again, you can't take your data, you can't take your analyses and modify them post fact. And stay tuned, because of course at SciTrain we have a number of great statistics courses that are about to launch. So keep tuned to what's happening at SciTrain, and we'll be in touch with more information about that when we get to that stage. But what about salami slicing? Like, I know about this in the context of chopping up pieces of research to get them published, like into those least publishable units. I might have a big study with a number of results, and I could publish that as one paper, or I might slice it up and publish it as 3 or 4 papers, which is not the best career-wise. But what about salami slicing in the context of data? And I like salami too, by the way, as well as cherries, Maria.
Well, yes. It's so sometimes it is justified, right? Whenever you have a big data, like there is a lot in physics, like there is a lot in genomic research, you have big tons of data, you have big data that is then analyzed in lots of different ways. People think up of an experiment with a specific objective to figure out the differences between this and that and what happens, but then you can get lots of information out of it, and some information is more important for some studies and for some audiences than others. So it's normal, for instance, whenever you have a massive birth cohort and you analyze 300 parameters, to publish some that are related to just endocrinology in one paper, and to publish others that are related to obstetrics in another paper. But that doesn't mean that it is, and it's easier to understand, it's easier to interpret, it's easier to organize, and people like to read simpler stories more, and you can provide a detailed description of what it is all the time. But it does mean that you have to have massive discussions in those papers most of the time, because you have to always take into account the big picture. You have to take into account that it's complex, that it has been analyzed in a context that was specific to that big data. And it may be reproducible, it may not be reproducible. So it could also lead to flawed meta-analysis, because it means that one birth cohort will be represented, for instance, in 30 publications, and another one that was written up as a single paper is just one paper. So it gets different weights whenever you are conducting analysis of your research, because you don't know, of course, with the identified information, if it's the same person, if it's a different person that you're talking about.
Exactly. And I would always encourage people to avoid least publishable units if they can. I mean, it's very tempting, especially as a young researcher, to put 3 papers out when you could just publish 1. But at the end of the day, it's much better as a career strategy to get that 1 paper that really makes a difference and goes into a decent journal with a decent impact factor potentially, than going for the numbers game. So do have a look at the reasons that we've put on this slide, the advantages and the disadvantages in particular of those least publishable units. Really, really important to avoid this as a potential ethical issue. And again, sticking with the food theme that we've got here in our 7 deadly sins of publishing and research integrity, what about double dipping?
So it's whenever you have the same data set for selection and for selective analysis. That means, for instance, that you are developing a model to explain something, and you have a population, a sample of people that you want to test for whose data you used to develop that model. You can't use the data from the same set of people to validate your model. You have to get another set of people and validate your model, because that just means that you are doing model fitting, that you are doing circular analysis, that you're inflating the statistical strength of the results, and to ultimately you can increase the the probability of having a lot of noise in your sample, so that you don't even are aware of what's important or significant anymore.
How often does this come up, Maria? I mean, in the papers that you see as a reviewer, and I know you do an awful lot of peer review work, like,
Mm-hmm.
helping authors get their papers in good shape for publication. Like, how often does this happen? How often are we seeing this?
It depends on the design, and most of the time, it's a matter of people not saying what they've done or not explaining properly what they've done. Because most people building models are aware that you need to take data from a place and then test it with data from a different place or a different setting or a different population, whatever it is. But they won't say exactly why they did it and what they did. They won't explain the proportion of data that was for testing and validation. They don't detail things in a way that you are able to trust what you read implicitly, that they've thought about everything that they should account for. And of course, you always need to present data from the data that you used to build the model differently, in a different way, in a different table, in a different figure, than the data they used to validate the model.
It's really important. And this was something I was actually unaware of, but this is circular analysis, where you unjustifiably inflate the apparent statistical strength of your results by using the same data, as Maria's
Mm-hmm.
talked about, for both the initial test and then for the model validation. Absolutely fascinating. I love also this whole idea of publishing negative results, and that's something that we get a lot from researchers. They talk an awful lot to us about this, like, I've got a negative result, can I still publish it? Because of course often you can't put negative results, or you'll struggle to put negative results into peer-reviewed journal articles. But publishing negative results is super important, right, Maria? We would encourage all of the researchers listening to this to do this, to put your negative results out there. But where?
Well, there's a lot of places where you can do it right now. There's lots of journals that will accept papers that consist solely of negative results. But the thing is that to publish a paper consisting solely of negative results, you have to justify yourself very well. It's much harder to then to write the discussion of your negative results papers, because you need to take into account all of the variables that it could account for not existing a difference, or your comparison showing no differences. So there are a lot of journals right now that do accept negative results. There are preprint archives, there are reports, there are protocol papers, there are a lot of ways that you can get research out there. And it is incredibly important to publish negative results, because then it doesn't waste resources. Because what people in your field are not going to repeat the experiments that you did to find the same thing that you did that was no difference.
It's like a community service. Like, if you do
Yeah.
something, you perform an experiment, you spend money to collect some DNA from a particular group of mice, like you're working on an
Yeah.
oncology project, and it doesn't work, you should share that result with the community so that somebody else doesn't waste their time and money as well. And this, I think, was brought really to the forefront during the pandemic, during the
Mhm.
COVID-19 pandemic, where negative and positive steps forward and back to do with the virus and vaccines were shared on preprint platforms like PeerJ, like F1000, like Research Square, bioRxiv, medRxiv, eLife, also very
Mhm.
important place for this kind of research to be shared, so that other people can quickly and easily see what's happened, what worked and what didn't work, and they don't repeat the
Yeah.
same mistakes. But researchers, unfortunately, because of the way that we're incentivized, often we aren't keen to spend the time, the energy to put our negative results out there. But it should be done, right, Maria? You'd agree with that, of course.
Yeah. And I think that there are people that are very talented in weaving their negative results into publications, because it is a story, right? It's a story of how you got to the results that you did ultimately.
Absolutely, absolutely. And so in this presentation today, what we've done, we hope, is solved a few problems with Maria and Gareth and taken you through the different components of all of these different common mistakes. And of course, finally, the peer review process is really, really important as well, because authors often jump in at different stages of the peer review process, do things that they shouldn't be doing around this cycle as well. Maria, it's difficult to know what you can and can't do within the peer review process also.
Well, you're limited to the data that you see, right? So you need to implicitly trust that people have done the things that they've done, unless they provide you access with, data depositories, protocols that have been published before, all of those things. But it's not the peer reviewer's job to reanalyze all the data that you've done or to tell you what it is that you want to say. It's the peer reviewer's job to figure out if it's worthy of publication, if it's novel, if it's original, if it's going to bring something new to the field, and if people should know if it's good enough that people can trust what you've done.
Absolutely. And we're lucky to have Maria with us at SciTrain because she's an expert on the peer review process, having reviewed, I don't know, how many papers have you reviewed so far, Maria, to look at whether they be acceptable for passing into the peer review process? Hundreds, thousands, tens of thousands?
No, over 500 by now, I think, within the last 4 or 5 years, yeah.
It's a good opportunity. Everybody listening to this, get in touch with us if you'd like to learn more about the courses, the content, the webinars, the training that we provide at SciTrain, because we'd love to hear from you. Maybe you'd like us to come show up virtually at your university or to your research group and give a presentation. Have a look at scitrain.com if you'd like to learn more. But research and publishing ethics, really, really critically important, Maria. Just a few closing comments as we come to the end of this Publishing Integrity Week this year?
So, first of all, it's very important for you to describe and to state ethics board approval if it's necessary. For humans, for animal, for environmental safety, you can only submit to one journal at a time. You are not able to republish an article. You have to quote phrases and cite sources. Do not fabricate or falsify data of parts of images, because it's more and more people are looking into those sections. And then for authorship, you should be aware of what your role is within the paper that you're writing, and always state funding and any financial or personal relationships that could bias the work.
Absolutely, absolutely. So the slides that we presented today are just a taster, just a small taster of the kind of course content that we have available. But the 7 deadly sins of publishing and research integrity for researchers to be aware of: harking, cherry picking, p-hacking, salami slicing, double dipping, not publishing your negative results. You should always do that. And fabrication, as Maria has said as well. Maria, it's always fantastic to do these events together. We always have so much fun. Hopefully, if you're listening to this live on LinkedIn or the recording, we've solved a few problems with Maria and Gareth for you this afternoon. Maria, have a great afternoon. Hope you enjoyed Publishing Integrity Week, and we'll see you in the next event. Thank you, Maria.
Have a great weekend. Bye-bye.